In lesson 1.6, we look at different types of transformations that you perform on your parent functions as well as some other functions that they give you. So what you need to remember later on in this lesson, and as you're going to see in your math lab assignment, they're going to say, okay, graph your original absolute value. And you've got to recall your original ordered pairs. So you can use this first page of your notes as a reference later on when you get asked to graph the cubic function, the quadratic function, cube root, square root function, and so on. So for example, all of your parent functions are identity graphs, and recall that's your basic graph before any transformations have been performed. You've got your constant function, which you don't really see a lot in this section, but I thought we would hit it anyway. Horizontal line, and the equation of it will look like y or f of x equals c, some number. So for example, this equation would actually be y equals 2 or f of x equals 2. Identity function is y equals x or f of x equals x. And it always has a positive slope of 1 and passes to the origin. Your absolute value function, f of x equals absolute value of x. These ordered pairs are on your absolute value function. And the next one, quadratic, y equals x squared. And notice your original points on this graph as well. I got these points, of course, just by taking any x values and plugging in and then getting your y. Negative 1, 1, 1, 1, so on. Your square root, once again, I got these original few points by taking x and plugging in. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. Notice in this square root, they only give you the positive version. We don't include the negative. It doesn't say plus or minus, so you don't have to worry about the negative portion of it. Then your cubic graph, you have y equals x cubed. And notice these original points that are also on your graph, 0, 0, 1, 1, because 1 to the third power is 1. Negative 1 to the third power is negative 1. 2 to the third power is 8, so on. Cubic root function, you've got the cubic root of x. So the cube root, on your calculator, you will have this button. Looks like this. And you can type in like 3, hit that key, and then take the cube root of any number. So 3, hit that key, 8 should give you 2. Cube root of 8 is 2. The cube root of negative 8 is negative 2. You can take odd roots of negative numbers. So those are your basic points that are on your graph for your parent graphs. All right, what we're about to do with this, we're going to do all types of transformations, horizontal slides or shifts, vertical slide shifts, horizontal stretching and shrinking. Different types of transformations. So the first two that we're going to look at are vertical and horizontal shifts, which just means your graph doesn't change shape. You're just sliding it around left or right for horizontal, up or down for vertical. A vertical shift in your equation looks like y equals, then you have your function, plus or minus some number at the end. So the number has been added or subtracted at the end overall. This simply moves your graph up c units. If you have plus c, or plus some number, it's going to move it up. If you have minus a number, it's going to move it down that many units. So a vertical shift or slide is exactly that. Meaning that if I've got plus 5, I'm moving it up 5 units. As you're going to see in a minute, horizontal shift would be the opposite of it. So in a vertical shift, notice that your x-coordinate is always going to stay the same if it's just a vertical shift, but your y-coordinate changes. All right, for a horizontal shift, in your equation, you've got a number added or subtracted inside grouping, specifically with x. It's going to move your graph left or right, opposite of the sign. So for example, I've given you a quadratic function. It's got minus 3 specifically inside with x. This actually moves your parabola to the right 3 units, and you would actually add 3 to your x values. If you have plus c, subtract c from all x's. If you have minus c, you add c to all x's. C is just any number. Notice in this case, for a horizontal shift, when it is specifically added or subtracted with x, your x changes, but your y stays the same. So notice the difference between vertical and horizontal shift. Vertical, added numbers are subtracted at the end, and you do exactly that. If it's plus, you move up and add. Minus, you move down and subtract. Horizontal, it's the opposite, and it's got to be inside grouping, specifically with x. Okay, the next type of transformation is a reflection. And there's two types of reflections. You can have a reflection over the x-axis because your minus sign is going to be in the front of your equation. And notice that x is going to stay the same. All I'm doing is I'm taking a graph and I'm flipping it over. If I'm flipping a graph, any point over the x-axis, notice that my x value is going to stay the same, but my y would actually change signs. And this is what it looks like in your equation. You're going to have a negative sign out front. That is a reflection over the x. A reflection over the y-axis, you have a negative sign inside, specifically with x. Notice the difference. This negative sign's outside over the x-axis. This negative sign is inside. This is a reflection over the y. This is telling you that, hey, you're going to change the sign or do the opposite of all your x's. So that'll make them flip over the y. But my y will stay the same. So the x's change sign, your y's are going to stay the same. In number 4, the next type is a vertical stretch and a vertical shrink. You notice that you'll have some number out front multiplied to your function. If c is greater than 1, it's going to stretch this graph out vertically and pull it away from the x-axis. So if I'm taking a standard parabola, it would actually just pull it and stretch it very tall in a sense, pulling it away from the x-axis. If your number that's multiplied out front is between 0 and 1, or in other words, a decimal or a fraction, it's actually going to shrink your graph and push it down closer to the x-axis. In this case, since this is a vertical stretch or shrink, your x is going to stay the same, but you multiply your y coordinates by that number to get your new y's. So if this is 1/2, I'm going to multiply my y's by 1/2, or take half of them. If this number is 3, I'm going to multiply by 3. If this was a -3, you would only have to worry about the 3 because the negative sign gets taken into account when you do reflections. Okay, what we're about to do, we're going to go over one more transformation on the next page. And then we are going to transform some graphs. Okay, last but not least, and this is a lot to take in, so make sure you study over what you're supposed to do, and then there is a certain order to applying transformations mathematically. Number 5, horizontal stretching or shrinking is opposite of the vertical stretch or shrink. Notice in this case, your number being multiplied is specifically with x. If that number is greater than 1, it's actually a horizontal shrink. It's going to push your graph in towards the y-axis. If your number is between 0 and 1, meaning a decimal or a fraction, it's going to horizontally stretch your graph and pull it away from the y-axis. And you're going to see what that looks like in a minute. And in this case, since my number's with x specifically, of course my x's change and not my y's. Remember, for a vertical stretch or shrink, we multiplied our y's by c. In this case, we divide all of our x's by c to get our new x values. Okay, you'll be taking parent functions and other functions and performing different transformations on them. And this is what order you have to apply the transformations in. First, you do a horizontal shift or slide, so we add or subtract from our x values. Second, we do any vertical stretching or shrinking, as well as any horizontal stretching or shrinking. So we multiply or divide x's or y's by that c value. Third, we do any reflecting over the y-axis or the x-axis. Remember, if your negative sign's out front, it gets reflected over the x. If the negative sign is inside with x, it gets reflected over the y-axis. Fourth, vertical shifts or slides. That's the last thing. So the last thing we're going to do is move our graph up and down and add or subtract to our y-coordinates. Okay, this next example has already been done for you. In this particular example, we say use the graph of f of x. So your original graph is in blue, and these are your original points on that graph. We want to graph this new function, g of x, equals function f being transformed by adding 1 to x and minus 2 at the end. But actually be very careful. This plus 1, notice, is inside specifically with x, so that is a horizontal shift. We actually left 1 unit. Remember, when it's with x, we did the opposite. So we're going to subtract 1 from all our x values. Then this minus 2 at the end, it's at the end overall, so that's a vertical shift. We're going to move our graph down 2 and subtract 2 from our y-coordinates. This is actually a very easy transformation to see and do without having to do any work. However, I wanted you to see what it looks like if you do it step by step. But I'm going to show you later on how you don't have to do any work for these. So we would take our original points and recall the order. Notice I've got it in the order that we perform it. You do any horizontal shifts, then you do any stretching, shrinking, and reflecting, then finally vertical shift. We have no stretching or shrinking, no number multiplied out front, no number multiplied with x. We don't have a negative sign out front or a negative sign in front of x, so there's no reflections. So the only thing we have is numbers added or subtracted. So this says we're going to actually move our graph left 1 and then down 2. So all you have to do is take every point on this graph and move it left 1 and down 2. So notice this new point moves here. I take this point, move it left 1, down 2 places, left 1, down 2 places, left 1, down 2, left 1, down 2. And then you just plot your new points. If you want to see what that looks like to your order pairs, these were the original. So the horizontal, moving it left 1, notice we subtracted 1 from every x value. So that's how I arrived at all of these x coordinates, subtracting 1 from the x. Then for the y, we had this vertical shift of -2. So I subtracted 2 from all of these y's. And that's how I got my new points. So you can do it that way if it helps you. But to me, if I can just see it and manipulate my points on the graph, then you can do that. You can also use Desmos to double check once we get into the actual functions you can type in. Okay, next. All right, 1.6. I've already got some notes made for you on this as well. In this particular graph, they want us to use this original graph we're given, f of x, and they want us to graph this new function g that has taken f and been transformed. Notice that 2 is multiplied out front overall, so that's a vertical stretch. Remember, if it would have been inside with x, it would be a horizontal stretch or shrink. But it's been vertically, it's a vertical stretch. You need to go through your equation every time and look back at your notes and think, what is this number doing? What is this value doing? How is it transforming my graph? This +1 is a horizontal shift left one place. The -1 at the end is a vertical shift down one place. And so what I want to do, that's the first step I do. I go through, figure out what's happening. Then I write the order which I need to perform these transformations in. Notice I did not create a whole list of order pairs and then keep doing math to those order pairs, because I want to show you how you can figure out what's happening, put it in order, and then perform it. Okay, so the first thing, according to my order that I wrote down in my notes, I always perform horizontal shifts first, and I do have one. So we're gonna take every point, and I'm gonna move it left one place or subtract 1 from your x coordinate. So left one place from every x. Then what I'm gonna do while I'm there, I'm gonna multiply my y by 2, because that was the vertical stretch. So remember, if you have a vertical stretch or shrink, you multiply your y's by that number, even if it was 1/4. And then third, then I'm going to subtract 1 from every y, or move my point down. So move down 1 to take into account the vertical shift. And those are the only 3 things I had happening. So let's start with this point. Start any place you want. So I'm going to start here, and I'm going to move my graph. I'm going to move this point left one place. Then I'm going to multiply my y's by 2. So notice that my y coordinate here is 0. If I multiply that by 2, I'll get 0. So I'm staying in this spot. I don't move from that spot. But then my last thing to do is subtract 1 from y, or move this point down 1. So all I got to do is move it down, and there's my new point. Let's do the same method here. So moving this point, I got 3 things to do. Let's move it left one place. So I'm here. Then if I multiply my y, which is -4, by 2, I get -8. So then I have to move this point down 1, 2, 3, 4 more points, because I'm doubling it, and this y value now becomes -8. So already at -4, -5, -6, -7, -8. And I moved it left 1. So I have performed steps 1 and 2. On step 3, it says subtract 1. So move it down 1 point further. And you can use a pencil just like I'm doing to make sure that you can stay in your spot. And then at the end, we'll go back and fill it in. Okay, so notice that these points. All right, let's do our math on this one. So once again, we're going left 1, so we're here. Then I multiply my y value by 2. So this becomes 8. So I'm already at 4, and I just need to go up 1, 2, 3, 4 more places to 8. Then the last thing was I actually moved that point back down 1. So here's my new point, and I'm done. Okay, this point, we're going to move it left 1. If you multiply that y of 0 by 2, you get 0, so we don't move anywhere. But then the third step says move your point down 1. So that point moves here. Now my new graph, I performed all those steps on every point, and just connect your Okay, notice that we had a vertical stretch of this graph. Okay, so there's your new function g. All right, number 3. You have this original function, this piecewise graph. Notice these are open holes as well. That really doesn't matter, except for the fact that as you perform your transformations on those points, just make sure wherever you move them, you leave them open holes. Okay, so this is my original function, f of x, and they want me to graph the new function g that has transformed f in the following way. You have a vertical shrink because you've got this 1/2 multiplied out front, and it's less than 1, so that's a vertical shrink. Then you have a negative sign out front, so this is a reflection. And since it's out front, it's over the x-axis because it's telling you you're going to change your y-coordinates. You have a number added inside with x, so that's a horizontal shift left 3 places. Plus 4 at the end is a vertical shift. We're going to move our graph up 4 units. So if we go in order, we've got our horizontal shift that we're going to subtract 3 from the x. And then we do any stretches or shrinking. And the only one we have is a vertical shrink, and we're going to multiply our y's by 0.5. Or take half of every y coordinate. Then third, we're going to reflect over the x-axis, which simply means all we're going to do is change the sign of our y. So, for example, if I was reflecting this point over the y, it would just move 2 places this way. So you just reflect it over, change the sign of your y coordinates. Fourth is a vertical shift. That's the last thing, always the last step. And we're going to add 4 to our y's, so we're going to move our points up 4 places. So once again, notice I don't have a list of ordered pairs, which I can show you that if you think that would help you. So let's go through the steps. So step 1, we have a horizontal shift. So I'm going to take every point. Let's start here. I'm going to, if I've got a horizontal shift to the left 3 places, I'm going to move this point left 3. So 1, 2, 3. My next step says I do a vertical shrink. So I'm going to multiply this y coordinate, which was 0, by 0.5. So I'm here. If I multiply that by 0.5, I'm at 0. Then reflecting it over the x-axis, well, I'm on the x-axis, so you can't reflect it over. Like, I can't change the sign of 0. It is just 0. So I'm still here. So I have performed steps 1 through 3, and I'm still here. So vertical shift, the last thing. Now, we can move this graph up 4 units. So we're going to move it up 4 places. So 1, 2, 3, 4. That's going to be our new point. Yeah, I got a hole in my paper in there. So then let's do the same thing with this point. Or well, let's go ahead and do it with this one. If I move this point here left 3 places for the horizontal shift, 1, 2, 3, I'm here. Then I'm going to take into account this vertical shrink, multiply y by 1/2. Once again, multiply this by 1/2, and I get 0. I can't reflect it over the x-axis since I'm on the x-axis, so it stays. Last thing, let's move it up 4 places. So 1, 2, 3, 4. And now we have to transform our open holes. Start here, move it left 3 for step 1. Then I'm going to take into account my vertical shift. I'm going to multiply my y by 1/2, or take half of it. So if I'm here and I take half of this, then I'm going to be at -1. So it moves me to -1. So I moved it left 3, took half of my y, so it moves me up to -1 on the y-axis. So we're here. Then I'm going to reflect this point over the x-axis. So if I'm here and I reflect over the x, it's going to put me here. Also notice another way to say that is change the sign of your y. Well, if I'm here at -1, my y changes to +1, so I'm here. So we've done steps 1 through 3. Then the last thing is I take this point and move it up 4 places for my vertical shift. So if I move this up 1, 2, 3, 4 places, it moves me there. Let's do the same thing with this point. Move it left 3. Multiply this y by 1/2, so you get -1. So it moves you up on the y-axis to -1. I reflect it over the x-axis, and I move this point up 1, 2, 3, 4 places. So here's that graph, and here's this graph. Okay, last but not least, we're going to look at a square root. You have some problems later on in your math lab that are like this. You have this original graph, and this is a case where I told you you have to know your parent function, which is square root of x, only the positive part. These are ordered pairs, 3 ordered pairs that are on your original graph. Square root of 0 is 0, square root of 1 1, square root of 4 is 2. Now we're wanting to, this is your original, and we're wanting to perform this transformation on your graph. Notice that the number you have is actually multiplied inside specifically with x. So this is a horizontal stretch. Remember, it's opposite. If that number would have been outside, that's actually a vertical shrink. But if it's a fraction inside with x, that's actually a horizontal stretch. This number is added inside specifically with x. Inside, you can consider a square root grouping in a way. So it's inside with x, so that's a horizontal shift, and it's actually going to be left 2 places. The negative sign is inside specifically with x, so that's a reflection over the y-axis. If the negative sign's with x, then it's over the y, so it's opposite. If the negative sign's outside, then that's saying you're changing, so that would be opposite and be x, if that makes sense. I probably just maybe confused you a little bit more. Okay. Your horizontal shift, subtract 2 from x. So once again, go through your equation and figure out what all is happening, and then make yourself some notes. We have to do them in this order. The horizontal shift always comes first if there is one. any shrinking always comes second, even if it's horizontal or vertical. Step 3, you change the sign, step 3, your reflection, and then last but not least, vertical. But there's no vertical shift, so we're not moving this graph up or down. If there was a vertical shift, you would see a number outside the square root added or subtracted at the end, but there's not. Okay, so let's take these 3 original points and let's apply these 3 steps and see what we get. If I start here and I take this point and I shift it left 2 places, then I'm here, and then I'm going to divide my x coordinate by 2. But if I divide 0 by 2, of course I still get 0. So the last thing, we change the sign of my x coordinate. Well, if I change the sign of this new x, which is -2, it becomes +2. So I flip it over so you can say flip over y-axis. So once again, I moved it left 2 places, divided my x-coordinate by 2, still get 0. And then I'm flipping this point over the y. So it moves from here over the y-axis to this spot. Once again, you can use a pencil, that way you can erase and then adjust as needed. Let's do our transformation on this point. So first thing, I'm going to move this left 2 places. Notice that my y-coordinate, my x-coordinate is 1. Second step is to divide that by 1/2, or multiply your x by 2. So if I'm dividing this by 1/2 or multiplying by 2, then my new x becomes 2. So I already moved it left, and then my new x becomes 2. So now I'm at 2, 1. So that takes me back here. So did you follow that? Moved it left 2 places. I had to multiply my x by 2, so that gives me a new order pair of 2, 1. So it moves me back to +2, 1. But then guess what? I have to take that point and flip it over the y. So if I'm here and I flip that point back over the y, it moves me here. Okay, let's take this point and perform our steps. Move it left 2 places. Multiply that x-coordinate by 2, so you get 8. So once again, the y don't change, but now my new x moves to 8, so I have to go to 8, 2. So that's going to be 3, 4, 5, 6, 7, 8. And now I'm at 8, 2. And then I flip that point over the y-axis. So let's go to 8, 2. So if I flip that over the y-axis, I'm actually changing the sign of x. So I'm at 8, 2, so my order pair is going to become -8, 2. So 1, 2, 3, 4, 5, 6, 7, 8. And then here.